Yeah, this is our team. We are from Saint Gobain Glass, Sriperumbudur complex, and it is 177-acre complex, and we have three float lines, one quarter line, and two quarter lines, and one mirror unit. Next slide, please. This is about our company. We have three float lines. Individual float lines are there in Sriperumbudur plant, and we have one automotive glass plant is also there. That is called a Securate. And we have two quarter lines, coated glass lines, and one mirror line. And we have two solution lines, solution in the sense it is advanced flame proof glasses, like this bulletproof glasses also there, like that glasses will manufacture in solution lines. These are solution line facility. And also we have one more facility inside our campus is this windows. And now it has recently started, and that business is also going very well. That is windows manufacturing plant. That is also inside our campus, and this is one of the largest installation which is ever done in the globally. It is very this is the largest plant in global. Okay, this is about our company. And next slide, please, Subhani. Next slide. This is our sustainability target, and we have committed today to reach our zero net carbon emission by the year of 2050. And this long-term goal must be guide our strategic decisions and must be guide to factor to ensure our team to coherence and their additional commitments. And we have committed to net zero carbon emission in the year of 2050, and we have committed to reduce our water consumption 50% by the year of 2025. This is our main sustainability target. Next slide, Subhani. And these are all the various areas we have focused in front of sustainability. One is water management, and in water management our goal is 100% self-reliant. And second one is waste heat recovery from all the float lines. Actually, when we are in the glass manufacturing process, the waste heat from the furnace, we are planning to utilize it, and we are planning to put a power generation system already, which is installed in float 2, and we are planning to install in two more float lines. That is the waste heat recovery system. So then when it is coming to the furnace operation, 100% LNG is our main focus, and green dispatch without wood packing. We are not at all, nowadays we have moved 90% of packing into green naked dispatch. Earlier it was, we have used wood packing and all. Now it is completely just naked dispatch. Next one is energy consumption reduction and increase in usage of renewable energy. Next slide, Subhani. And this is our water conservation details. So why we are going for this project? Our daily freshwater consumption is too high. In the year of 2017 and 19 and all, the consumption was okay. The consumption was around 1093 kiloliters per day. And the next, our water source. There are two sources are there. One is RWH, second one is external source. When I'm telling you this external source means it is from the SIP card or from the TTRO, which is supplied by our SIP card team. Our aim is to achieve 100% sustainability goal of 515 KLD by using reduce, recycle, and reuse concept. And this the project scope is involved in float and transformation lines in WGC street perimeter. How we are going to achieve this? That is by using there are two methods. One is consumption reduction, second one is conservation. These are the two steps we have followed to achieve this water conservation. Next slide, Subhani. This is our water consumption trend. Here you can see in the year of 2019, the water consumption is around 1093 KL per day, which means kiloliter in a day. Then after taking so many efforts, we have reduced our water consumption. We have reduced our water consumption to 726 KL. By using these various projects like float and adiabatic cooling tower changeover and mirror ETP recovery, steam condensate recovery, recycling water flushing, and spray nozzle, these are all the various actions we have taken. In the upcoming slide, I'll explain all the projects in detail. This is our strategy. Actually, when it is coming to the water management, we have followed only two steps. One is consumption reduction, and second one is conservation. When it is coming to the consumption reduction, we have followed reduce, reuse, and recycle concept. In this reduce and reuse and recycle concept, we have arrived some of the project. Total savings of the project is around 240 KLD, kiloliters per day. And when it is coming to the conservation, we have expanded our RWH1 capacity from 58,000 to 80,000 KL. So all the detailed projects are coming in upcoming slides. Then this is one of the major projects which we have done in our float one cooling tower. See, the cooling water system is a major important critical system in the float glass manufacturing system. Here we earlier we used to have this kind of left side before picture is there. No, this is the conventional cooling tower. Earlier we used to use this conventional cooling tower. In this cooling tower, the main disadvantage is the evaporation loss. Here around 100 to 150 KL of cooling water will get evaporated, and daily we have to top up 100 to 150 kiloliter of water. Now we have, when we are doing this cold repair in the year of 2020 and 2021, we have replaced this conventional cooling tower into adiabatic cooling tower. In this adiabatic, the main difference when compared to this conventional cooling tower, the evaporation loss is completely zero. There is no evaporation loss. Only 30 to 40 KL of water will be used for the spray purpose, and that is also we can able to recycle it. So the total investment of this project is 3.5 crores, and the savings is around 30 lakhs per annum. And this is one of the major projects which we have done in our plant. This is low TDS recovery. The savings is around 50 KLD. We have collected all the wastewater from our DM plant and cooling tower and WHRV blown on water, and we have collected into the common sump. From there, we have pumped in by using the transfer pumps, and then it is transferred to the pre-treatment plant. There we have removed our suspended solids and turbidity and everything. We are removing it, and again we are using it for a raw water. Using the same water as a raw water to our DM plant. So the total investment of this project is around 7.5 lakhs, and the savings is also there. This is one of the major projects which we have done in our mirror ETP. Here also the savings is around 40 KLD. In the mirror plant, we used to use the DM water for the glass washing and polishing purpose. After the glass washing, the water will come to the ETP. There we used to have a UF ultrafiltration and RO system. What we have did, we have increased the RO number of membranes from 6 to 12 number of membranes we have increased. Thereby, the savings got increased from 50 KLD to 90 KLD. Directly, there is a 40 KL of improvement was there. And this water we are using it for our cooling tower makeup purpose. And the total cost involved in this project is 6,43,000, and the savings is around 70,52,000 per year. Next slide, Spawn. This is steam condensate recovery. The waste heat from the float to line, we are using it for our to fulfill our steam requirements in various locations like canteen, HFO tank, ESP, and quarter DHUs. So the water which we are using for the waste heat recovery is a DM water. Earlier, we don't have any condensate recovery system for the quarter 1 and 2 DHUs. What we have did, we have installed a condensate pump, pressurized power pack pumps we have installed after laying the pipelines, and the same water collected through this condensate pump, and we have transferred to our, again we have recovered to our boiler, and thereby we have saved around 40 KL of water. And the total cost of the project is around 32 lakhs, and the savings is around 17.5 lakhs per annum. Next slide, one. This is a toilet flushing by using the RO reject water. This is phase 3. Actually, the entire campus is now we are using this toilet flushing water is recycling water only. So the RO reject water, earlier we used to use this filter water for our toilet flushing. Now we have changed all the filter water into RO reject water. Earlier the RO reject water was used for the garden applications. Now we have moved into this RO reject water. The total investment of this project is 19.5 lakhs and the savings is around 2,92,000. In water it is coming around 10 KLD savings. So by doing all these projects, we have reduced our specific water consumption from 0.91 to 0.36. So this is per ton of scale per ton of saleable glass.
This is regarding this RWH1 expansion. Earlier, we are having the RWH1 only. In 2017, we have constructed the RWH2, which is of 72,000 KL, and old RWH1 is of 58,000 KL. Now we have taken the help of CRN and developed the catchment area, increased the catchment area from 58,000 to 80,000 KL. Since our new expansion, new roofs also has been connected to this rainwater harvesting ponds. And now here we are having that total is of 2,10,000 square meters of roof has been connected to this rainwater harvesting ponds. How we have connected this rainwater roof is by using the symphonic system. This is the EPAN symphonic system we have installed in our campus. The main good thing of this one is, even if there is a 1 mm rainfall will be there, the water will be collected and it will be thrown into the respective ponds. This total area we have connected into 2 ponds now. So one side it will come to RWH1 and other side it will go to RWH2. This one is the water. We are letting out the water from our campus.
Here you can clearly see the RWH1, no, the connected load is too high. 1,60,000 square meters connected to the RWH pond 1 itself. So hence the load connected to the RWH1 is too high. When the monsoon starts at the earlier stage itself, RWH1 will get fulfilled. At that time, we used to let out the water to avoid flooding. Next slide, Subhani. This is the overall trend of, one second, hold on. So this is the overall trend of water let out quantity at the time of monsoon time. Here you can clearly see from in the year of 2020, we have let out around 66,000 of KL of water. And when we are after the expansion of RWH1, we have not let out much quantity. In the year of 2021, it is around 5,000 KL, and in 2022, it is completely zero so far. Next slide, Subhani. Yeah, go ahead.
These are the construction photos that during the expansion of our catchment area for the RWH1, without disturbing the existing structure. Only we have constructed the outside walls so that it will withstand the water load, and then we have. Earlier, we used to save only 3.5 meters of water, height of water. Now, at present, we are saving 4.7 meters of height, total depth of the water. The total project cost has been invested so far is 1 crore for this one. Earlier, the catchment area is of 17,000 square meters. After the expansion, the catchment area is of 18,181 square meters.
So this is just an annual rainfall and rainwater harvesting data. Here you can see in the year of 2020, for the rainfall of 1,829 mm, we have harvested around 2,26,000 kiloliter of water. When it is coming to the 2021 data, when we have received the lowest compared to the 2020, the value of rainfall is low, around 1,600, but we have harvested around 2,53,000. This is the main outcome of this project. We have for the lower rainfall also we can able to harvest around 2,53,000 K. And so far we have harvested around till late it is coming around 402 mm of rainfall. We have harvested around 72,000 K of water. And this is our water source data. In the year of 2020, we have in the graph in this graph the green color indicates our RWH water, and the gray color is indicates SIPCOT and tanker water quantity. In the year of 2019, the RWH water usage was very low. 2020. After doing this modification, we have improved our RWH water usage. In the year of 2021, it was around 72. Now we are at 82, and our goal is 100% RWH water usage. Next slide, this one. And these are all the outcomes of this project. Freshwater consumption has been reduced from 1093 to 726 scale, and RWH water usage got increased from 22% to 82%. And the people involved in those various functions, functional people also involved, tech service IUCs and EHS and OSSP people also involved in this project. The people involved in various organization level and operation to the top level management. And innovation and best practices established fully automated mirror ETP RO plant and steam condensate recovery system. There is no electrical energy consumed. It is only a steam operated pump which we are using. And online pH and TDS meter also we are using in the same ETP. And the digitalization of flow meters that is already done for the ETPs. And RWH pond water volume monitoring. That is earlier we used to measure this measurements by manually. Now we have changed everything into digital mode. Now the system is to be implemented in common ETP. This is the next project we are planning, that 125 KL. So by doing this, we can able to achieve around 515 KL. That is our sustainability target. The system is very much adaptable and reproducible in other business also, where the ETP and STP is involved. Next slide, one. So this is one of the digital initiative which we have taken. Earlier, we used to measure this RWH 1 and 2 level. Manually, we have to measure. And here trip and slip hazard was there. Now we have installed ultrasonic sensor, and it is directly communicated to our clouds. We can able to get the data from the cloud itself directly. There is no other manpower required for measuring this data. Next slide. This is next RWH 2 pond. Here also we have installed the ultrasonic level sensors to measure the RWH pond level. Next slide, this one.
And this is regarding some of the green belt development that we are doing inside our campus. The thing is that that not only we are using the water for the campus, and also some of the water we are using for the green development also.
Okay.
Without wasting.
How you are using this produce? You are saying medicinal plants, fruit bearing plants, and others. How you are putting this into common usage, if at all you are doing that?
This one we are developing a concept of this urban forest, sir. In this urban forest, we are using all the 40 native plants of this area, and we are developing these plants based upon.
So these plants, do they require a lot of water or very less water? How's that? How did you come to a conclusion on this?
This one, sir, we are developing this one with the help of a horticulturist, and we will select the plants based upon this water consumption, and also the water leaf falling, the maintenance, leaf falling, always this cleanliness and all will be there. All these things also will be considered, and also the soil erosion, also how to eradicate this soil erosion. Upon all these things, we are developing this.
Okay.
It consumes very less water only, sir. And the water also we are supplying to this urban forest. It is completely a recycled water. It's not a fresh water. It's just a recycled water.
So recycled from what all applications?
Recycled from our wastewater, like filter backwash, from our WTP wastewaters are there, no? Like filter backwash, low TDS waters will be there. Those waters we are using it for our garden applications.
I hope
Like
the
cooling pipes,
quality standards are also taken care
yeah,
of.
yeah, yeah. It
Yes,
is,
sir.
it is
Yes, sir. Yes,
completely
sir.
it is taken
Otherwise,
care
these plants cannot sustain.
of. Sustain. It's,
Not only plants, but the soil also has to be taken care, isn't it? Soil.
Yes,
yes,
sir.
yes, sir. Exactly, exactly.
Right.
Okay.
And these are the number of, as of now, we are having 137,000 trees inside our campus. We have started our campus with 13 number of plants in the year 1995. And this top view photo, what you are seeing is the recently, which was inaugurated by Mr. Honorable Chief Minister.
Okay. Okay.
This is the scrap pad, sir. We have converted this scrap pad into like this.
So you are open to any visits, any industrial members or anyone who wanted to know about how this is done. Can we arrange such visits to your plant?
Yes, sir. Yes, sir.
Sure, sure.
Earlier, from the Bosch also, some people has been visited. And after this opening, from Hyundai also, one team has been came and visited how we have developed and all.
Okay. Okay.
And recently, from Ashok Leyland also, they are also got one OSR land. They also came from the SIPCOT. They got the news that we have developed in a good manner. They came and asked us how you have developed it and in what basis.
Okay.